Hi everyone, hope you are doing good. So in this video, I will talk about completable future that was introduced in Java 8, and basically it was introduced to overcome the many disadvantages of future. Both are implementation of future tasks. So completable future is particularly useful in the scenarios where multiple tasks need to be performed asynchronously and possibly combined later. So we can see both are used in asynchronous programming, but they differ significantly in terms of features, flexibility, and ease of use. And there are many advantages of completable features like non-blocking. It lets the implementation of tasks have no blocking of threads, and flexible and concurrency. Now we can see the differences between future and completable future in more detail. So first, it has blocking nature. Future has blocking nature. We must call get method to retrieve the result, which blocks the thread until the computation is complete. And no manual completion is possible with future, and limited functionality. It lacks the method for chaining, combining, and handling exceptions as well, and no cancellation support. While we can cancel a task using cancel, it depends on the underlying implementation whether the task is actually stopped. Thread management typically used with executor services, and these are the advantages of completable future over future. Like it is non-blocking, and we can perform non-blocking operations via methods thenApply, thenAccept, thenCompose. Manual completion is possible by using the methods complete and complete exceptionally. Chaining and combining is possible to allow the multiple asynchronous tasks running fairly, and exception handling is robust in this case via methods exceptionally and handle. And built-in async methods are supported like supply async and run async. So here, with different examples, I will show the uses of different methods of completable future, and two other examples are for exception handling. So in this example, I have taken one object name is one class name is user details, and in this user ID is another class, and that name is the method. So I have created one executor services object, and it is having 5 threads as of now. And this is the object of the completable future, and supply async method is called to instantiate the user ID with the value 1. Then this user ID will be used in the further task. But if we see here, then apply async method is used. That means this until this method is executing and doing its task, the current thread will not be blocked. And but whenever value will be available here, it will definitely used here. But this is not blocked because of this one. So that's why these are async in the nature. And once value will be available here in the user details future object, it will be used here. So here we are printing get username based on the user details object. And get method is used when get method is used to denote the completion of the future objects task. So this is the program, and I will try to run it. Yeah, so we are getting value here as XYZ. Here we can reduce these number of lines via lambda expression. So I will quickly use this one. So yeah, with lambda expression, we can achieve in this way same methods, but less number of lines in the code. Yeah, so now we can see example of exception handling in both the cases for future object and completable future object. So here I have taken 5 threads object of executor service and instantiating 3 different future object for different tasks. So first one F1, second one is F2, and third one is F3. So if I see here in get callable method, I am executing the task. So here in task 2, I deliberately thrown one exception, that is runtime exception. So it should be caught somewhere in my code. So here while retrieving the while F2 task is executing, I have handled the exception in this way. And here it will be printed exception occurred and the message, and other two tasks should run properly without any interruption. So we will see this one by example. Yeah, so if we see here, task 1 is completed successfully and it's printing its thread name that we are trying to print here. So thread name is printed, but in task 2, exception is occurred. So exception related message is printed and it's handled properly. And now task 3 is executed. So we can see the result of task 3 as well, that is current thread name. So this is the way of handling exception in future object. And now we will see completable future related exception handling. So here I am running 3 tasks via run sync method. And here if we see this code, completable future all of. So it will run all 3 tasks, and if any of the task throws exception, then it will be handled via this method. So here I will check by example because it will be more understandable in that way. Yeah, so task 1, 2, and 3 started asynchronously, and task 3 completed, task 1 completed, but task 2 give an exception because we are throwing runtime exception deliberately here. That's why it is printing exception related message, but other 2 tasks done successfully here. Then only main thread finished. So this is the way of handling exceptions in case of completable future. It is more robust, I will say. Yeah, thank you.